Hi students, welcome to Year 10 Science and the Space topic, and this is video number 5, looking at astronomical distances. We've started to use a couple of these terms before, so I thought it was important that we just explain what each one of them means. So the first, and probably one of the most common terms that's used in astronomy, is the light year. Now, a light year is actually a measure of distance. It's one of the important things to be aware of because we see year and we think time. But in fact, a light year is a measure of distance. It's a measure of the distance that light would travel in a full year. Now, if we look at the fact that light travels at a speed of 300 million meters per second, then that means that it will travel 300 million meters or 300,000 kilometers every second. So if we multiply that by 60 seconds, we get how far it travels in a minute. Multiply it by 60 minutes and we get how far it would travel in an hour, and so on. 24 hours for a day, 365 days, roughly. You can put 0.25 if you want. And that gives us this ridiculously large value of kilometers, okay, into the million, billion, 9.46 and a little bit trillion kilometers in a single year. Now, that's a ridiculously large number, so we use scientific notation in order to simplify it a little bit, which brings it down to 9.46 times 10 to the 12 kilometers. That's a big distance. But Proxima Centauri, taking out the Sun, is the next closest star to us, and it's 4.2 lots of that away. So the distances in the universe are oftentimes a little hard to comprehend. They're so massive, and so some of our units have actually changed to try and help us cope with these massively large numbers. Certainly much easier to talk about 4.2 light years than 4.2 multiplied by 9.46 times 10 to the 12 kilometers. Probably more interesting to us is the fact that the Sun is just 8 light minutes away, so you can probably do a calculation to help you work out exactly how far away that is in kilometers. Another important astronomical unit is the parsec. Now, a parsec I have mentioned previously when we were talking about how we convert apparent magnitude into absolute magnitude or luminosity, and we regard that as being equivalent to putting all the stars at a distance of about 10 parsecs. Now, I mentioned there that a parsec is equivalent to 3.26 light years, so you have actually seen this before. How we calculate it is by using the phenomenon of parallax. In this case, we use star parallax or stellar parallax by looking at how an object appears to objects that are behind it when you are looking from different perspectives. You may have done this simply by sitting at one point in a room, holding your hand up in front of your eye, closing one eye and lining your finger up with a particular object on the other side of the room. Then if you close the open eye and open the closed eye, then you find that what happens is that it appears that your finger has moved. Obviously your finger hasn't moved, but from the perspective of the background has changed just a little because you're looking at it at a slightly different angle. Now we magnify that a little bit in order to make use of that when we're looking at astronomical distances, because we are comparing stars with stars in the background, and we do that by looking at it from different perspectives of the Earth's rotation around the Sun. To give you a little bit of an idea before we look at the diagram here, each angle, so if you think about a circle, is 360 degrees. Each degree can be separated into 60 minutes, and therefore each of those minutes further into 60 seconds. So therefore 1 degree is equivalent to 3,600 arc seconds. Or, as I've written it here, 1 arc second is then 1 over 3,600ths of a degree. So that gives us this little diagram here. If we look at the fact that the Earth is in 2 different places at 6 monthly intervals, what we do is we look at a star and we line it up with a background stars, And as a consequence of that, if the angle is equivalent to 1 arc second, then we know that the distance, straight line distance between the star and the sun is going to be 1 parsec. So this here will be 1 parsec. We'll have a look at that in a minute. Now this distance here is an important one, and it's what we're going to talk about in the final slide. There is a calculation that you can do in order to shift between distance and the degrees in parsecs, in arc seconds. So, and I've included that there for you just to have a quick look at. The final one is the astronomical units, and this is specifically astronomical units as opposed to units that we use in astronomy, and I've been a little bit probably sloppy in my language during this video, because we do have something called astronomical units, and the astronomical unit is the distance between the Earth and the Sun. So effectively the radius of the Earth's orbit, given that it's not rotating exactly in a perfect circle as it's shown here. This is equivalent to the astronomical unit. So 1 AU would be equivalent to the distance between the Earth and the Sun, which is around 150,000 million kilometers. So therefore we can also define the parsec as the distance in which 1 astronomical unit subtends an angle of 1 arc second. So you can see here is 1 parsec here, which is the distance between the star and the sun. We subtend the angle by looking at the astronomical unit in comparison to where the Earth is, and then as observers we then look at the star in comparison to its background. So hopefully this just gives you a little bit of an introduction to some of the important units that we use in astronomy. Thanks for watching.